Hi there, young scientists and engineers. It is I, one of your science teachers, and in this video, we're going to be looking into what's known as orbital speed. Okay, orbital speed describes essentially how fast planets orbit the sun, or really how fast an object would orbit a heavenly body. Here are the objectives for this session. Now let's begin by saying what might not be so obvious, and that's the fact that the heavens have always fascinated humans, right? Since time immemorial, people would cast to gaze upon the heavens and wonder. Planets, stars, and the moons have always been of interest to human beings. Before astronomy became an organized science, uh, ancient civilizations have already noted down and studied, right, what was happening uh, in the heavens. Okay, in primary school, or might be in year 7, we learned that planets move around the sun. This moving around the sun, we call it orbiting, right? We say that planets orbit the sun. Okay, that means they move around, they go around the sun. Now, the shape of the path, right? The shape of the path or trajectory that planets follow is either circular in shape or elliptic in shape. Okay, so for the most part, the orbits of planets around our sun in our solar system would be circular or elliptical. When I say circular, there's going to be a center to that, right? There's a center of a circle. The same way for a circular orbit, there's also a center. And what's located, the center of a circular orbit would be, of course, our own sun, right? Our star, the sun. Right, let's do some math. That is supposed to be a circle, and we are noting down some quantities in that circle, namely the so-called radius. Now here's a circle. Then circle has a radius from your previous studies. It also has a diameter, which is twice the radius, and it has a circumference, right? So the idea here is you're going to put your sun at the center, and then we're going to find out how long it takes for a planet to go around, right, an orbit. Right? How long does it take to go once around the sun, given, of course, a radius? Okay, so the math that we're going to be using has a lot to do with what we learned previously. Right, let's have some examples. Some idea then of the orbital speed, the orbital period for planets. The orbital period is the time it takes for a planet to go once around the sun. The orbital period is long for planets that are far away from the sun, and this orbital period is shorter for planets that are closer to the sun. Right, so let's check that out. Mercury would be the planet closest to the sun, and that has an orbital period of 88 days. Right, so Mercury completes one complete rotation in 88 days. Neptune, on the other end, 165 years. Oh my, 165 years. That's how long it takes for Neptune to go once around the sun. Where's Earth? Okay, Earth's here, 1 year. What's that? 365 and a bit days on a non-leap year. That's how long it takes for the Earth to go once around the sun. Okay, that's the orbital period. Okay, so this slide summarizes the orbital periods of the planets. Okay, in our solar system. Now we're going to assume that the orbits of the planets, including the Earth, are circular, And in order to calculate the orbital speed, we basically need to know two things. Thing number one is the orbital radius, and thing number two is the time period, right? The orbital radius is how far, right? How far is the planet from the sun? Okay, how far from the sun? That's the orbital radius. The time period is how long it takes the planet to go once around the sun. Okay, how long to go once? Does that make sense? Around the sun. Okay. When you say how long, it's not a distance, hey, it's a time. Okay, in this context. Okay. So here are some orbital speeds for your reference. Neptune, the orbital speed of Neptune is 5.43 kilometers per second. Saturn, 9.69. Oh my, these are really, really fast. Venus, 35 kilometers per second. Earth is about 30 kilometers per second. Now, I'm going to try and put this in context, hey? IFC to Pacific Place, that's, oh, I don't know, about 2 kilometers, right? About 2 kilometers. So you're going to IFC from Pacific Place, that's 2 kilometers. If you do that twice, that's 4. And if you do that in 1 second, right? 1 second, Neptune is still faster than you. Okay, so you would need to go to IFC, Pacific Place, IFC, Pacific Place, and then what? Maybe halfway through in 1 second. That's how crazy fast Neptune is. And that's only Neptune because, as you can see, the other planets here have a greater orbital speed. All right, let's try our hand in some math. You can pause the video if you want. Please study the example on your screen. Moving on. All right, here's a question that we'd like to do. The answer is there, but let's look at the steps. Right, in any and every question that we will attempt at GCSE, the first step is to remember a relationship. That's what we need. Right, R is the orbital radius. It's how far the object is away from the sun. T is the orbital period. Orbital radius is R, orbital period is T. Now, after you've remembered an equation, right, so you get to recall this, recall, right, remember. After that, ask yourself, can I use that relationship immediately? In this case, I can. So because I can, the next thing I do is I'm going to go and substitute numbers into that equation. Okay, so I'm going to figure out what R is, and I'm going to figure out what T is, and then stuff these two values in my relationship. Okay, here we go. All right. Now, the next thing we got to ask ourselves is, are the units making sense? In this case, not yet, because the period is in days. I got to make that into seconds. I got to turn that into seconds. The same way, that is in kilometers. I got to make that number, right? Convert that into meters, right? And here's what we're doing in the next two steps. After you've done that, you can then reevaluate. Okay. And then expressing final answer and also remembering the units. Now, this is an orbital speed. It's a speed nonetheless. So the units, just like we learned in year 9, meters per second. Let's try another one. Right, you can pause the video here and then give it a shot and then continue with the video and see if your answer is right. Okay. First step, right, remembering a relationship. and then asking yourself if we can use that relationship as it is. Okay, there's no need to rearrange. Okay, in this case, it looks like there's no need to do that. Next step is we're going to substitute, right? And then we ask ourselves, are these units making sense? Once again, no, they're not making sense because the time is in minutes. We've got to convert that to seconds. That's what we're doing in that step. Distance, the radius is in kilometers. We got to convert that to meters. Here is what we're doing in that step. 1,000 meters is 1 km, right? A kilo means 1,000, just like a kilogram is 1,000 grams. 60 minutes is 1 hour. 60 seconds is 1 minute. And of course, 24 hours in a day. Right, so having converted these quantities, all that remains to be done now is to evaluate. There we go. And then expressing our answers, like so. Remembering, of course, that the units are meters per second because we are calculating once more speed. Okay, let's try another one. First step is remembering a relationship and then asking ourselves, do we use that relationship directly? It looks like in this case we can't because this relationship, this equation, is an equation that's going to solve for the orbital speed. But the question is not asking for that, it's asking for the orbital time, right? Orbital time. So we need to rearrange that equation. Okay, we're looking for the period, not the speed. Okay, so we got to rearrange that relationship. Okay, rearranging gives us this. And then we ask ourselves, yeah, we can substitute now. Okay, that's what we're doing. There we go. There we go. All right. Are the units making sense? Well, the radius is in kilometers. That don't make much sense because we got to convert that to meters. The velocity is in meters per second. That's good, okay, because that's a speed. All right. What we can do now is substitute these values, and then we can evaluate. All right, here we go. Now you can express your answer here in multiple ways. You can leave the time in seconds. That is a big number. You can convert that to minutes. Still a big number. Looks like it's more manageable for hours. Okay, 1 Earth day. Okay, 1 Earth day. I don't know if that's surprising to you, but still, right? 100, what, 40? Not 140? 1,440 minutes. Okay. The objectives of this session are as follows. You can have a read through them. Right, red would be the non-negotiable. And you're meeting expectations if you're in the orange. And you want to challenge yourself, then you are in green.